Hello everyone, and welcome to today's PV Tech Talk webinar, Sungrow Energy Storage Systems, Technology to Stabilise the Grid. I'm Andy Colthorpe, Editor of Energy Storage News at Solar Media, and we're especially proud that this webinar is hosted by PV Tech, the world's oldest and best solar PV technology website, jointly with Energy Storage News. Some of you may not know that Energy Storage News first began in 2014 when it was actually called PV Tech Storage, launched by our publisher Solar Media. The growth of the energy storage industry has followed the immense success of solar PV closely. Bloomberg NEF has forecast that more than 400 gigawatts and 1.19 terawatts of cumulative installations will be made worldwide by the end of 2030. That industry growth has come hand in hand with technological evolution. We have seen many interesting technology trends already in battery storage in areas from battery sub-chemistry selection to safety equipment. Sungrow, meanwhile, is one of the world's leading solar inverter brands with a strong background in R&D and innovation and bankable products used in projects all over the world. The company has also become a leading player in battery energy storage systems, or BESS. As you will hear in today's session, technological evolution and R&D of the type Sungrow is known for in the solar industry is applied just as firmly in Sungrow's energy storage activities. Sungrow's latest BESS solutions, the PowerStack Commercial and Industrial Systems and Power Titan for large and utility scale, are based on cutting-edge technology, including liquid cooling systems with automatic coolant replenishment. Today, we will hear why PowerStack and Power Titan offer answers to some of the ongoing challenges faced for battery storage, with smart design that reduces cost and footprint, as well as the liquid cooling that regulates operation and maintains safety. Our speaker today is Jingdong Qin, Sungrow's Senior Manager for Battery Storage Solutions to the European market. After a presentation from Jingdong, I'll be asking him a few questions about Sungrow, its best solutions, and how they were designed and developed. As always, interaction with you, the audience, is very important to us. We will host a short Q&A session with audience questions after the presentation and interview. Please put your questions for Jingdong into the tab on the right-hand side of your screen. Now, we can't promise to answer all the questions we get from you in the short time that we have, but Sungrow representatives will be happy to continue any conversations offline and engage with your questions and queries after this session. I'd also just like to inform you that today's session is being recorded, and access to the recording and slides will be sent to all registered attendees. It will also be available on demand from the PV Tech website in a couple of days' time. With that, I'd like to thank you once again for joining us and give a warm welcome and introduce Jingdong Qin. Over to you, Jingdong.
Hi, Andy. Thanks, Andy. Hello, everyone. I think now let me introduce today's topic, Sungrow ESS, technology to stabilize the grid. At the beginning, from the front page, I think you can see there are two products. PowerStack applied for C&I market, and Power Titan with PCS station applied to utility market. And this is our latest PCS product and published in 2021. People know Sungrow because of its PV inverter business, but after 25 years development, we have 10 business segments. Today, we will focus on energy storage business. We officially entered the energy storage industry in 2016. And starting from the NMC battery, we have mastered the characteristic of LLP, and we can provide two integrated solutions. As of today, we have 0 fail incident in our delivered project. It's quite difficult. And at the beginning, like most manufacturers, they focused on product solution. But after the market experience, we no longer just provide a solution from the product side. We provide a suitable solution at a high level and optimize, develop our products according to needs. And we can see some Sungrow's performance numbers here, like 36 annual growth rate and $3,766 million revenue in 2021. And another two numbers, 35 gigawatt shipment in 2020 and 47 gigawatt shipment in 2021. What about this year's revenue? Probably we can touch the 60 gigawatt shipment. We will see. And wait for the annual report. Another message, like this year is 25 years anniversary of Sungrow, and we are keep our bankability at the first rank for consecutive years. Regarding the application of energy storage, and I personally call it market request or market demand for energy storage solution from the front meter, utility side, and behind the meter. At the front meter side, the ESS connect with renewable energy to do rapid control and energy shifting. And the traditional power plant connect with the ESS to do the frequency regulation and backstop, for example. For the utility side, the ESS need to support the grid to do the frequency and voltage regulation and ensure stable power grid and when the grid has failure. Behind the meter, the ESS to do the arbitrage microgrid and increase the self-consumption ratio. The rate comes from market change. This is what I think. And like these slides, because of intermittent and unpredictable feature of renewable energy resource, after being connected to the grid, it will cause a fluctuation in voltage and frequency, even lead to a particular accident, power outage in some regions. And abandoning wind and solar energy can realize effective using of energy and leading a waste. The gap between the peak and valley increased day by day, and the current carrying capacity of power grid and the peak shipping pressure are gradually increasing. Meanwhile, with the gradual withdrawal of primary energy from the power generation market, more and more renewable energy connect to the grid. It needs some capability of the electronic devices. It had a good capability to support the grid and to do the low voltage and high voltage ratio without disconnecting from the grid. And a stable operation in weak power grid with SCR less than 1.2, and to do the power grid support and the fast response, and with the VSC technology to support the grid. And another point, like the off-grid mode support, for example, the Black Star. The challenge on the grid side and the power generation side has been mentioned in previous slides. But there are also some challenges in the project execution phase. For example, CapEx, OpEx, and safety. CapEx is, I think, is quite simple to understand. The initial investment and the main factor like market mechanism, electricity price, the currency, and the visual operating, personal salary, and social political, etc. And from another side, like solution side, we provide a DC solution or AC solution, or complete solution, battery plus PCS plus MV, MU, EMS or PPC. Those equipment or solution by one company or multiple company, and the product certification and product design, and the product function, etc. Another factor, the service side, the service strategy, and product availability. Those factors affect the CapEx. And second, the OpEx. After passing the site acceptance test, our equipment enters to the commercial operation period. Some factor like service quality, the service response time speed, and spare parts supply, and the warehouse, whether they are faster turnover parts, etc. And another factor, the product stability. So for example, if the service quality is poor and the product performance unstable, it will cause losses of benefits. Like 100 megawatt power station can only output 90 megawatt due to maintenance, and cannot perform 100 megawatt grid frequency regulation service. And the grid company probably think this ESS station is unqualified and they're not ready to participate in new grid service bidding. The third point, the third challenge, the safety. It's simple, but is the hardest point. And it can be summarized in 3 points: the component safety, warning system design, and prevent heat spread system design. For the component safety, like the component selection, the safety, electrical safety design, all your design meet or exceed the standard. The warning system design, like early gas detector, combustible gas detector, and pressure relief design, exhaust system, and audible and visual alarm devices, etc. To prevent the heat spread, gas and water-based fire extinguishing system, and waterproof about integrity. A simple question to audience: is there any mistake made by the site engineer? I'll give it 5 seconds. It's okay, thumbs up. I think it's quite simple, like the PPE. And therefore, to meet the needs of various scenario, I think we have launched the following two product: Power Titan ST2752UX, applied to utility market, and Power Stack ST500CP-IC50HV with EMS 3000 CP, applied to CNI market. Those two products or two solutions are based on liquid cooling technology platform. And we can provide liquid cooled and air cooled system solution according to the project request. But before introducing our product features, I think we can do a briefly discussion of failure incidents. In the past 10 years, we had more than 50 fail issues happened. It's quite big. This has a great impact on our energy storage industry, and will even slow down the industry development. And there are various reasons, and I summarize for 4 points: integration, electrical protection, earlier warning, and the prevention of thermal runaway. At the integration side, some entrepreneurs in the no battery industry or renewable energy industry and think the ESS, just PCS plus battery, and some equipment collected together in one battery in one container, and simply connected by building blocks. So it leading a frequent accident. Another one, electrical protection design, equipment linkage and independent protection mechanism when we do the design. And alarm system, for example, in one energy storage system, the battery account for the largest cost, and some faults come from the battery early warning mechanism and alarm delay. Just for the thermal runaway, just like in the instructions of the safety challenge, how to deal with the fail issues before, during, and after. A complete protection solution can prevent or reduce the probability of fail issue, but sometimes the customer seems to be very sensitive to this part of investment. So I think the energy storage system solution is a system level. It's a system level solution rather than the product itself. With liquid cooled system technology, we can reduce LCOS by 20%, well, improving operational efficiency and in smart OEM, and friendly for installation. The liquid coolant adapt water ethylene glycol, which has high heat conduction and better heat uniformity, intelligent temperature control based on the battery cell temperature and operating condition, adjust the liquid flow speed and automatically adjust the heat exchange power. Thereby, we can reduce the auxiliary power consumption roughly like 40%. And the rack level has DC, which can realize rack level energy management and the mixed use of old and new battery in the same battery container, and reduce the damage of short current and reduce the bucket effect. For the smart OEM, you can do the remote system upgrade and fault detection and prediction. For the installation friendly, our product, our PCS and battery cabinet are pre-installed and transported design. After equipment is transported to site, only the cable works are need required. Previous project challenge with high LCOE, the factor of this, according to this high LCOE, like footprint, area, and difficulty in maintenance and installation, and bucket effect of battery, and the minimum energy management unit is container level. With our new technology, for example, the Power Titan, we can do the back to stack and the side-to-side arrangement to reduce the footprint area. And the auxiliary power consumption reduced by 40%. And we have the DC-DC integrated and boost the discharge energy by 7%. This is tested by this value tested in our factory. And we can also to do the O&M cost saving. So, and an important factor affecting battery service life is the temperature. A large temperature difference can cause a rapid aging of battery service life, which also put forward better requirements for heat exchange design. In traditional solution, the battery difference in one container, we can do 10 degrees Celsius, even more. The Power Titan power stack has good temperature control. The temperature is in 3 degrees. At the same time, according to our calculation, the service life can extend to 10% and energy by 40% based on 100 megawatt hour project and 05C 1 cycle per day, and the EUL is 65%. A new technology could improve 80% O&M works, like SOC auto calibration, just one button click, no need to system shut down, and easily to do the system upgrade through the control platform. The software can be upgraded remotely. And comparing the past, we need an engineer upgrade the system one by one and on site. And the dynamic replenishment of coolant. The coolant in the liquid cooling system will volatility over time and generally need to be replenished in 3 to 6 months. The cabinet has a liquid store tank, and the system performs replenishment according to the liquid flow and the liquid level, and reduce the manual operation and saving O&M cost. At the safety design, our understanding that safety design starts from the smallest devices to overall system protection, from the cell, module, to string and containers, and it requires engineers to be familiar with component features. Protection part, electrical linkage protection, logical design, and fire suppression system design. The system can do early warning, real-time detection, gas or water-based fire extinguishing solution, and how to prevent the spread of thermal runaway. At the electrical protection part, the liquid product adopt a multiple level fuse protection to reduce the losses caused by short current fault, like pipe level, rack level, and the combiner box and the PCI side. The thermal runaway protection design is based on the concept of minimizing losses. The fire protection system solution is not isolated, I think, because and it should be considered from the overall perspective of the product, such as the structure, material, and the design standards. Compare with the single battery compartment design, Power Titan adopt independent compartment design, as shown in the left picture. There are 2 battery chambers, and the middle one is the electrical compartment. Each battery cabinet integrates heat, smoke, temperature sensors, and a water pipe. Integrate And also we have the fail-proof bucket integrated to achieve 1 hour fail resistance capability. For the fail system integration include water pipe, outlet flank, combustible gas detector, exhaust system, and we have the aerosol option for waterlogged regions. At the CNI application, we can provide an integrated solution, battery, PCS, EMS. For customer side, we only need one conductor for product upgrading and maintenance. The product has passed IEC 62443 and GDPR data security test. There another challenge from the grid side. It requires the power electrical converter need to support the grid. And because more and more renewable energy connected to the grid, the power grid become more complex. And the cost of power grid upgrade is high, and the construction period is long. Therefore, it needs our power converter can have the capability to operate in weak grid and fast response time and support the grid, provide energy continually. For the challenge of the weak grid, our equipment has ability to operate under the grid condition with SCR equal to 1.018. You can find we have the test post. It from 4-point low voltage and high voltage right through the power quality control, and with this kind of analogy, our converter equipment can work at weak grid and support the grid energy supply. Otherwise, the system will be shut down. The customer economic losses and the manufacturer's brand losses, I think, can be calculated. The second challenge for low voltage and high voltage right through is needed the equipment that's the lost grid connection in short period. In China, we have done one test. One power station use Sungrow power converter equipment has passed the test of 800 grid, and this equipment performance exceeds the requirements of the test center and provide high quality power supply. Like the harmonic less than 1%, grid voltage imbalance less than 0.5%, and the DC component 0.15. 2 seconds in low voltage right through and 100 milliseconds in zero voltage support. And between 1.1 rated voltage and 1.2 rated voltage for a time cycle with disconnecting from the grid. And active power response time for the PCS, we can do 20 milliseconds. And the power equipment can also pass a real test and provide 100 reactive power output. In actual case, with our previous generation of containerized PCS, the whole site passed G99 and DC service. In other side, we can say our new PCS also has this capability. And for Sungrow has a deep understanding of the fast response. In order to achieve fast power grid dispatching, our protector support GOOS protocol. And also the PCS equipment has a VSE working mode, which can realize motor replacement. The role of a converter is changed from grid following to grid forming. Ensure the stable output of the renewable energy, and fast adjustment tracking the voltage and the frequency. In some region, the ratio of renewable energy connected to grid continues to increase. If the ratio is less than 50%, it requires the power converter operate in grid following mode. And if the ratio more than 50%, the grid become unstable and complex. Passive power grid following is no longer applicable, and at this time, I think it's necessary to actively support and stabilize the power grid. The power electronic conversion equipment need to have a multiple characteristic which adjust the voltage and the frequency. The moment of initial is adjusted to achieve the stability of power grid. The VSG mode can be used to replace motor, and the VSG requires the power electronic equipment to have mechanical and the electrical magnetic features of rotating motor to realize primary and secondary frequency and voltage regulation. Working at a VSG mode, the virtual initial and drop factor can be adjusted according to the project request. And the equipment detects the voltage and the frequency of the power grid, and the performance in internal loop control to realize drop control, and self-balancing, and damping oscillation control, and the surprise sudden change in grid frequency. And in this picture, we have first Black Star application in United States. This is used our previous PCS technology. And if the PCS working in VSG mode or have this function, we can say we can do the Black Star requirements of 100 megawatt level. For Black Star request, usually it needed to be discussed and coded separately. It needs to detail load list and start sequence and peak power. And also we need to build a test preform in our factory and adjust the control program internally. And in addition, after the product delivered to site, our R&D expert will also send to site to do the site support, debugging, and optimize the program to ensure the grid connection smoothly and function realized. And this is our today final part. It's about Sungrow application scenarios. We have 5 gigawatt hour of contract signed of liquid cooling system and 1 gigawatt shipment in our days. And we have 3 gigawatt hour shipment in last year. In this, here is some examples. Some examples of our case and grouped for 4 parts. One is independent power station, renewable energy plus ESS, CNI, and the residential energy solution. This is our largest and first 100 megawatt level project in Europe. It uses our last PCS technology and passed the G99 DC service of the station level. And also it brought a good benefit to our customer, roughly like 30,000 pounds per day. But initially, the equipment investment is roughly around 250 million RMB. For this project, we didn't receive the DC service but at the later stage of site commissioning, clients has told us they're willing to attend this service. For Sungrow, it's at that moment it's a new challenge, and also it's good opportunity to verify our technology capability. So we have organized an expert team to introduce and including our R&D team, standard research expert, and site engineers to build a test platform in factory and the programming and calibrated on site in the next day. So we successfully realized the DC service and passed all the tests within 3 weeks. So thank you, everyone. I think today's topic will stop here, and next turn to Andy. Probably we have some questions from the audience to discuss about today's topic.
Sure, thank you very much, Jendong, and thank you, of course, to all of our viewers and listeners today. We've got lots of people on, and we've had, fair to say, lots of good questions asked. Now, as we said before, we aren't going to have time to go through all of them, but I'm very happy to say that I think we'll be able to deal with some of them, and some of the questions that I wanted to ask. Again, very happy to see that, in fact, the audience are asking some of the same questions, Jindong. So let's start with, I'll give you an easy one, let's say, to begin with now. So, yeah, we talked a lot about obviously the product and, how it was designed. But, in terms of customer service and customer support, how does Sungrow assist and support customers in solving the problems of stabilizing and serving the power grid, and kind of what would you say are the advantages of Sungrow and working with Sungrow? Oh, bless you there.
Okay, thank you. That's a good question. And for example, for European market, we have the local team support, and they are, for example, the local pre-sales and the after-sales team over the Europe, and we have the after-sales expert group, and we have the pre-sale energy storage technology center to support each country. And we also have several typical project commissioning experience up to gigawatt hour in North America. And I think second 2 point, like Sungrow has been engaged in power electronic conversion technology and grid connected technology for more than 20 years. Like this year, we are 25th year. And so we have deep research on the access standard and the grid service of various countries, and we have the specialized expert on standard and grid connection and grid experts, and also we regularly send our expert from the headquarters to provide on-site guidance. I think this is our way to assist our customer to service their concern or the problem. Yeah.
Excellent. And yeah, I think it is really important, obviously, to be able to have those experts that can directly support your customers, as well as taking them great products. Obviously, it's great to engage with the customer and give them the assistance that they need. And I guess you guys are able to do that quite globally as well. But moving on, there's a question. I think it's a very popular type of question, let's say, from the audience, and it's about the type of battery suitable for battery energy storage system. So I guess there are several different types of system, with I guess lithium being the obvious big kind of headline there. But do you want to just maybe briefly explain your thoughts and Sungrow's thoughts on the kinds of batteries used for battery energy storage systems?
Yeah, I think you are right. Currently, there are many kind of battery technology on the market, like a lithium-ion based battery and fuel cell and sulfur battery. But I think a lithium-ion battery is preferred technology for utility scale application. And among the lithium-ion battery and LFP phosphide is the preferred technology. And also we heard a new topology like a sodium-ion battery, expected to have a better temperature and suitability in high and low temperature, and with high charge speed. I think it's still on the study side. And but at the same time, I think energy storage solution is a systematic project. It's not a single product, and battery technology is one of the links. And I think for the grid service side, the PCS technology plays an important role, and also the system integration capability affect the stable operation of the entire system. No, this is my ideas. Yeah.
Sure, and there's a lot of thoughts about batteries, and I think clearly we see sodium ion. We hear that there's a lot of big companies see some potential. Big companies and small companies see the potential with that, but I think, as you rightly say, it can sometimes people can not necessarily focus too much on the battery, but it can be forgotten how important all those other components are at system level, really, I guess. And moving on, there's another question that, again, I think quite a few of the audience members took an interest in. And this is around safety and security of systems. Now, again, to the audience members that sent in quite detailed questions on this and other topics, we aren't going to be able to go into very, very detailed discussion here. But as we mentioned before, Sungrow experts will be very happy to continue conversations offline. But Jindong, for the purposes of this discussion, do you want to just tell us a little bit more about how Sungrow considers the security and safety of the system?
Okay, and thank you, Andy. I think this question is also another challenge to me, and I, from my angle, for Sungrow, the safety issue of energy storage system is, I think, probably separated for two parts. One is hardware part, and another is system level control. For example, as I mentioned earlier, the liquid cooled product powered item has two compatible and compartmental design, and the cabinet wall are made of fireproof material. And I think at the designer side, the safety requires of various place, the safety standard requirements of various place, and need to consider it. And like some standard like MPA series and the UL 9540A. And the battery technology for lithium phosphide, which has a low activity and a high melting point. And for the fire protection system solution, we probably need to integrate like a combustible gas detector, oil gas detector, and some sensors like a temperature and a smoke sensor, exhaustive system. Even we adding the explosive proof panels, like water, like the water spreader system as another option or aerosol. And at the system control level, the second part, I think, through understanding product characteristic and with the field experience and the system linkage protection mechanism with all kind of design, we can to avoid the thermal runaway in earlier stage. And also in Sungrow side, we have cooperated with many university and to study the mechanism of battery thermal runaway. And we think only by understanding the cause of thermal runaway that we can provide that we can avoid the risk in early stage. Yeah.
Right, of course, yeah, and it's just safety is absolutely, absolutely essential to any industry, really, I suppose. Um, but it's a slightly related area, I suppose, but not really the same. But in terms of the liquid cooling technology, I don't know
Mhm.
if there's anything you can tell us about how that was developed. And I guess the other side of that is that there are, obviously a lot of systems out there from Sungrow and other makers that are already deployed that were using air cooling technology. Do you think
Yep.
some customers would still prefer that? Will there still be some markets or some applications where air cooling is maybe going to be selected, do you think?
Um, uh, I think these are dangerous questions for some side, and for now I think the first point is the market need, because in the market more and more liquid cooled the solution presented. So our Sungrow, of course, we will show our capability. We have this kind of technology. We can do this kind of solution to our customer. On the other hand, the air cooling is not finished. It's not stopped in Sungrow. We, like I mentioned, nowadays we can provide air cooling and liquid cooling solution. Those kind of solution is based on system level, based on the customer needs. So we can we can provide a suitable solution based on the market needs and based on project needs. So that is my angle. Why this is my angle?
Hmm.
My
Absolutely.
point.
Okay. Okay. Sure. Sure. And we're going to skip to the audience questions now because I think we are running out of time a little bit, and really appreciate everyone's precious time with us today. So we had a couple of people were interested still on the cooling system, like roughly what sort of percentage of capex does the cooling system represent for the battery energy storage systems that you have?
I think I can probably give a rough example, like 2% to 3% of one project for the liquid for the cooling system.
Oh, okay. Okay.
Yeah,
Great.
capex part. Sorry. Yeah.
Yeah, and you said while we're talking about percentages,
Yeah.
you mentioned that the newer products are a smaller footprint with something like 32% area savings. Can you tell us a
Mm-hmm.
little bit more about how that was achieved?
Um, for the footprint saving, firstly, and like Power Titan for the utility scale, the Power Titan passed for example, it passed the crucial standard test UN9540 and designed by following the standard FPA series, and also integrate fail resistant material, and the single side door open. It's about side to side and back to back install, back to back arrangement. From this side, from this perspective, what the new technology can saving the footprint area by 32% with our internal calculation compared uh, compared to previous technology. Yeah.
Okay, fantastic. Jendong, I think we're unfortunately going to have to call an end to today's session there. As mentioned, really appreciate the audience's attention and time. So many good questions. And I think Jendong and all the team at Sungrow very much looks forward to engaging with all of you, following on with those questions and discussions, and really making our best efforts together to drive
Mhm.
forward the energy transition using smart technology. So thank you very much for your time as well, Jindong, and we'll look forward to speaking with you and with Sungrow again very soon. Thank you.
Yeah. Thank you, everyone.